Oh yeah, this lesson is going to be on it's AQA, topic 2, bonding. I'm going to take a look at ionic bonding. Here's a quick retrieval you can have a go before we actually start. So pause the video here. Okay, so let's have a look. So we're going to take a look at ionic bonding, and here's a little cartoon picture. What do you think you can see? Pause the video here and just think, well, what is this picture showing? Okay, what I can see is you've got sodium atom and you've got chlorine atom, and the sodium is throwing an electron to chlorine. Chlorine is accepting it, sodium is donating it. So the question is, why does that happen? Let's have a look. So we move on. Quick recap. Ions are elements that have either gained or lost an electron. So ions are charged particles. As metal atoms lose electrons, and don't forget electrons are negatively charged, they become positively charged ions. And as non-metals gain, so metals lose electrons, non-metals gain electrons, they become negatively charged. And here is an example. So you've got sodium here, and you can see what sodium is doing. It's donating the electron to the chlorine atom. So the chlorine atom has accepted an electron to become a chloride ion with a negative charge, and the sodium atom has donated its electron to become a sodium ion, and it has a positive charge. Now this results in chloride ion having a full outer shell, 8 electrons, and sodium having 2 in the electron in the first shell, 8 in the next one. So that means the outer shell, which has 8 electrons, is now also full. We move on, and you can see that. And the other thing you'll know is the electrostatic attraction between the positive ion and the negative ion is the actual ionic bond. And like I said, opposites attract. So, therefore, the sodium ion and the chloride ions are strongly attracted to each other. This attraction sticks the ions together, and it's what's called ionic bond. It's a strong bond. And you end up with a lattice, a giant lattice of sodium and chloride ions. So we're going to take a look at this. So pause the video here, draw the following ionic bonds. So you've got calcium oxide, magnesium oxide, and magnesium chloride. Don't forget, calcium, magnesium, both metals, so they will donate the electrons. Oxide and the chloride, or oxygen and chlorine, are non-metals, so they will accept electrons. So pause the video here and have a go. Okay, let's see how you got on then. So, in magnesium chloride, there's your outer shell for magnesium. Don't forget, magnesium has an atomic number of 12. So its electronic structure is 2, 8, 2. And we're only going to draw the 2 electrons in the outer shell. And that reacts with now, there's your chlorine atom, and that's got 1, 2, 3, 4, 5, 6, 7. So it can accept 1 electron to make magic 8, but there's still 1 electron there. So you're going to need another chlorine atom, because that will take this electron. So when magnesium bonds with chlorine, 1 magnesium atom requires 2 chlorine atoms, and this is what's going to happen. Now, because magnesium has lost the 2 electrons, the charge is +2. And each chlorine atom has gained one electron to become a chloride ion with a negative charge and a negative charge. And one thing you'll notice is two pluses cancel out the two negatives. And that's the ionic bond. If you look at calcium oxide, there. Now calcium is in group 2, so it's got 2 electrons in the outer shell. Oxygen is atomic number 8, so its electronic configuration 2, 6, meaning it's got 6 electrons in the outer shell. So it can accept 2 to make, so calcium loses 2 electrons to end up with Ca2+, it's lost 2 electrons. Oxygen gains 2 electrons, so it's oxide ion, 2-, and the 2+ and the 2- cancel each other out. So that's the ionic bond. And in an exam, this will probably be worth 4 marks. Here's some questions for you to do. You can clearly see there's a magnesium atom there and a chlorine atom. Describe in terms of electrons how magnesium atoms and chlorine atoms change into ions to produce magnesium chloride. It's worth 4 marks. So pause the video here. Okay, let's see how you got on. So magnesium loses 2 electrons. So you'll get 1 mark for that, 1 for that. And 2 chlorine atoms gain 1 electron each. So gain and 1 electron each will give you the 4th mark. We move on. This question is about magnesium and magnesium oxide. Magnesium oxide contains magnesium ion Mg2+, oxide ions O2-. Describe in terms of electrons what happens when a magnesium atom reacts with an oxygen atom to produce magnesium oxide. It's worth 4 marks, so pause the video here and have a go. Okay, so let's see how you got on for 4 marks. So here magnesium will lose 2 electrons and the 1 oxygen atom will gain 2 electrons to form magnesium oxide. And that's 4 marks. Complete the diagram to show the electronic structure of an oxide ion. Now it's giving you the information. The atomic number is for oxygen is 8. So use a cross to represent the electrons. Two crosses on the inner circle. And 8 crosses. Now, because the atomic number is 8, oxygen is 2, 6. But because this is an oxide ion, it's gained 2 electrons, you put 2 more on. So there. 2 crosses in the inner circle, 8 crosses in the on the outer circle. Worth 1 mark. Next one, the bonding in aluminium oxide is ionic. What causes the aluminium ions and oxide ions to be held together strongly? 1 mark. Pause the video here. Moving on. Opposite charges attract. Aluminium is Al3+, aluminium ion. Oxide ion is O2-, and it's the opposite charge that attracts. Sodium iodide contains sodium ion, Na+, and iodide ions, I-. Describe as fully as you can what happens when sodium atoms react with iodine atoms to produce sodium iodide. You may use a diagram in your answer, and it's worth 3 marks. So once again, pause the video here. Okay, so what you should, sodium atom will lose the 1 electron. Iodine atom will gain 1 electron. And that opposite charge, sodium plus and the iodine, I- will attract each other, forming an ionic bond. Okay, so with 3 marks. This diagram shows the structure of sodium iodide. Solid sodium iodide does not conduct electricity. Why does sodium iodide solution conduct electricity? Pause the video here and have a go. Okay, so the answer is, in a solution, the ions are free to move, whereas in a solid, the ions are in a fixed position and they're unable to move.